Okay, boys and girls, it's me, Mr. Wolders, your math teacher and your social studies teachers. Pretty much your teacher of everything except for the things that Mrs. Weiss and Mrs. Babalos teaches you. And I'm here to talk to you about the tower problem, only we're not interested in Act 2 here. We are actually, ladies and gentlemen, we are acting on Act 3. Tower problem, Act 3. All right, so here was the problem. The problem was that we had to build this tower, and we only had the tower partially built, and we were being asked to build a tower that was going to be as high as the top of this table. I didn't give you any numbers, I just gave you the challenge. There was no other information. So this is, in a way, is kind of what real life people experience when they deal with math in the real world. Just keep in mind, you actually live in the real world, but sometimes we don't do real world math in real world, that being school. So here is a good example, and you should have clued in that we have been working largely on recognizing patterns, and so there's going to be a little bit of a pattern in here, and we'll get to that in a minute. The first thing that we need to know is we need to know, what do we need to know? So I asked you, actually, what information did you need to know? And there's some things that we need to know. We need to know, for example, how tall is one of these stories, or how tall are these 4 stories that we have here? Actually, that's not 4 stories, that's only 3 stories. Now I could sort of eyeball this and sort of tell that, well, if 3 stories goes here, maybe the next one up to here, I could sort of eyeball it and make a little bit of an estimate. So I could figure out roughly, I'm probably looking at somewhere between 10 and 14 stories. Just going off this picture would be sort of a rough estimate. Now, some things I need to know. I need to know, how high is this table? How high are each one of these floors or these levels? These are some of the things that I'm absolutely going to need to know before I go about doing this problem. And some of you guys actually did that. So let's have a look what I did. So one of the first things, and slides out of order, so we'll go back to that one later. One of the first things I did here is I figured out that the table is actually 68 centimeters high. I need to build it at least as high as the table, so that's an important figure to know. Another important figure to know is how big are we actually talking about in terms of the toothpicks. And what we find here is that the full length here of 2 floors is about 12 centimeters, or in other words, we have here 1 floor for every 6 centimeters. So that's important information to know when I'm going forward here. You got to know what you're dealing with. Now, we had sort of played with this a little bit. You had to put together a building estimate based on the cost of materials. You want to be pretty accurate if you're being asked to do that thing. So a bunch of building estimates came in, and this is the kind of thing that, if I was at City Hall and trying to award a contract for somebody who's doing a estimate, it would be pretty interesting to deal with this. All right, so we got some pretty interesting estimates here, ranging from a high cost of $4 million to a low cost of, the cheapest one would be the AOK company here at $13,200. Now, if you remember, each beam was going to cost $100, and each fastener was $50. But we also had a cost for labor, and the labor was going to be, I believe we had a cost of labor which was $100 to install each fastener and each beam. So you had to take that into account in your estimate. So one of the interesting things to see on our estimates where we went wrong. Did we go wrong in our strategy, or did we just go wrong in our adding or multiplication? Now, one of the things first off the bat, you should notice that all of these here are hundreds and 50s. So any of these numbers here that have a 2 or a 3 on the end are a little bit suspect, because everything here is going to be in multiples of 50 or 100. So even something like $20 or $30 in the answer, it's just not going to be totally accurate. So it seems quite a bit too many to have beams of 476 and fasteners 952. First of all, that seems a little bit backwards. We would probably need more fasteners and beams. So somebody didn't really check here in the Metal, Steel, and Brick Company to see if their answer actually made sense. And if you went back and looked at the picture, you could see pretty quickly that we're not really going to be anywhere near 476 toothpicks to build our tower. So it's something lower than that. And it's probably not quite as low as 13,200 because we're probably going to need an even number of beams and an even number of fasteners. And also, these just seem kind of interestingly low. And it's also interesting that one company here, LAN Incorporated, had the same number of beams and fasteners as AOK, but they had two totally different cost estimates. This happens in the real world all the time. Materials are the same from two different companies, but they submit different prices. And so we got to sort of decide which would be the best price to go with. Now, I'll just tell you here right off the bat that one company here actually submitted a totally accurate bid, and they didn't do anything, and that was AW Limited, of a fixed price of $27,800, 100 beams necessary, and 52 fasteners necessary. There are some other groups like Marshmallow here. They were pretty close to that, as was Marshmallows Are Good. The Mather Builders were on the right track, and the Marshy Monsters weren't too far off as well. So there's some bids here that were pretty close. Let's look at how I put together my bid to come up with a pretty accurate cost. First of all, ladies and gentlemen, you'll notice that I applied the information that we needed to know. Well, what did Mr. Wolders do here? Well, first of all, he figured out what the measurement was going to be, and I applied that. And I draw myself a little diagram here to show myself, to make it sort of easy to count what I was going to need, and also to sort of make sense to my audience what exactly was going on. And so what we had is we had 12 centimeters was 2 floors, or 6 centimeters was 1 floor, total height of 68 centimeters. And I did some math here. I took my 68 and I divided it by 12. Now remember, 12 centimeters was 2 floors. I get 5.66. Or I can just take my 5.66 and multiply it by 2 now. Another way to do this would just be simply to divide 68 centimeters by the 12. And what we come up with here is we need 11.32 floors. Now you can't have 0.32 of a floor. So you're going to need at least 12 floors to reach the top of the table. So how did I figure out what all the pieces were that I was going to need? All right, so let's see how I did that. So I figured out we're going to need 12 floors. So I've got my 12 floors here. Floors going from 1 to 12 across the top. And on the very first floor, I counted, I'm going to need 8 fasteners, and I'm going to need 12 support beams. That's just to make one cube. So if there's going to be a pattern, I'm going to start at 8 with the fasteners. I'm going to start at 12 with the support beams. And you can see right here that I highlighted what my pattern was. And each fastener, each level you add after the first floor, you're going to need 4 fasteners. So it goes up 12, 16, 20, 24. Support beams 20, 28, 36, 44, etc. All the way up to 100 for a total number of support beams and 52 for my total number of fasteners or marshmallows. And one of the things I did really quick is I just checked to see if my work was accurate. And I noticed right off the bat I made a mistake here earlier. I added 8 to 36, but I ended up putting 42 right here. And so I had to go back and readjust all my numbers. So this is really important. Even a veteran math person like Mr. Wolders can make mistakes and needs to go back and check his work. So after checking my work, I was pretty confident I was going to need 100 toothpicks, 100 toothpicks, 52 marshmallows. That would it. I would have no leftover materials, and I would be able to build this thing no problem. And I could be totally confident, and I could be totally confident to the people that I was submitting my bid to that I, in fact, had a really accurate, really, really good bid. So let's see. All right. And so when I built this thing, I took a meter stick, I measured the top of the table, which is right here, and you'll see that exactly 12 floors, 100 toothpicks, 52 marshmallows was absolutely perfect. Now, I could have made it a little bit shorter, and I could have been creative. I could have saved some money thinking outside the box here, and I'll show you how you could have saved some money. So here's one way you could have saved some money is you could have taken out 3 marshmallows and 4 sticks, and you could have made a triangle at the top here to finish off. And this is what good builders do, is they find some creative solutions to save a little bit of money and on materials and labor. I would have saved myself here, well, 1, 2, 3, 4, 5, 6, 7 pieces. I would have saved myself $700 in labor. 3 marshmallows, which would cost $150, and then the 4 sticks or support beams, I would have saved myself a total of $700 plus $150 is $850. I would have saved myself a grand total of $1,250 on my estimate. I could have even come in a little bit under my bid. So, ladies and gentlemen, that is Act 3. That is the solution to the tower problem. Now, what I want you to do now is discuss it with your parents or discuss it with your partners and find out, why did you go wrong? Was it a problem of adding and multiplying, or did you just not have a good strategy to figure out exactly what you would need before you built it?